Now we're on page 14, and for question number 6, we have to solve this equation. So I see there's x's in the exponent, and what I'm going to try to do first is get common bases. You can't just solve this like a regular old algebra 1 equation. So I know 0.5 is actually 1/2. So I'm just going to rewrite that. And this whole thing 1/2 to the 3x plus 2. And I'm going to keep my 8 to the 5x minus 4. So what I need to do is convert my two bases. I have a 1/2 and I have an 8. So 1/2 is going to become 2 to the -1. That would put it in the denominator. And then I have my exponent 3x plus 2. And my 8 is going to become 2 to the 3. And then I have 5x minus 4. What happens when you have common bases, just like common denominators, they can cancel out. So just to save a little bit of space, I'm going to distribute -3x minus 2 and distribute 15x minus 12. So this is just a regular old algebra 1 linear equation. I'm going to add 3x to both sides. And just making sure I do get a fraction. That didn't look right. Cross out, cross out. So I have 10 equals 18x. Divide by 18. And let's simplify that. Divide them both by 2, and you get 5/9. Now we did logarithms way back in the winter time. So b has to be greater than 0, otherwise the denominator would be 0. We are going to evaluate this. So your logarithmic form, log base number equals exponent. A logarithm helps us isolate that exponent. Exponential form is base exponent equals number. So when I see this problem, log base b of 1 over b to the 3rd, so I'm going to put it in exponential form. Base is b. We don't know what my exponent is. B to the what gives you 1 over b to the 3. So I'm going to employ that common basis thing we just did. B to the question mark. I can say this is b to the -3. So what's our exponent? It's -3. Number 8, the expression 2 to the x over 16 can be written equivalently as what? Okay, I see a lot of weirdness going on here. I can't just divide 2 divided by 16 and say 1/8 because there's an x up in the exponent. But what I can do is I can rewrite this denominator with a common base. 2 to the 4 gives you 16. Now I can combine them. Just like if I had the problem x to the 5 over x to the 3, I would subtract my exponents and I'd get x squared. For this one, I can do the same thing. 2 to the x minus 4. We just don't know what x is. And that's where we got that. For the next one, it says, given the function f of x equals log base 2 of the quantity 2x minus 8, which of the following values of x is not in the domain? So for this one, x cannot be greater than 0. So what I can say is this thing in parentheses, 2x minus 8 greater than 0, and you solve for x. So we add 8 to both sides. So 2x is greater than 8, and x is greater than 4. That is what is in the domain. So anything bigger than 4. So if I graphed this, this is what it would look like. And right here, this is about 4. So they want to know what is not in the domain. So that means everything that's not greater than 4, oof, that's a tricky one, x is equal to 2. You could also look on tables and see where you get an error. For this one, which of the following equations is shown graphed on the grid below? So here, it's really hard to see. This is the y-axis right here. This is the x-axis. What I would do is just graph these. It looks like there is an x-intercept at 3, 0. When you put this into your calculator, this is the only one that has an x-intercept of 3, 0. Let's see what we got on the next page. We will do another video. This one's getting a little bit long, so tune back in.